For the past few months, I've been experimenting with different types of smoke simulation in Blender, and today I'll try my best to take what I've learned into this video. Okay, so the easiest way to create smoke in Blender is to use the Quick Smoke effect. So make sure your default cube is selected, go to Object, Quick Effects, Quick Smoke. Your default cube is now the smoke emitter, and this new surrounding box is the smoke domain. The emitter adds smoke to the simulation, and the domain object surrounding it contains the entire simulation. So to make room for more smoke, we have to scale up the domain. But as you can see, the smoke is lacking a lot of detail. That's because the resolution is too low. With the domain selected, we can head over to the Physics tab to increase the division resolution. Now, the smoke has a lot more detail, but everything is going a lot slower. This is not just because more data is being calculated, it's also because Blender is calculating everything within the domain. What we can do to prevent this is to use the feature called Smoke Adaptive Domain. This basically says only calculate where the smoke is. Now, we're still not happy with the quality of the smoke, but if we were to increase the division resolution again, the smoke would start to behave differently. That's because this value doesn't only represent the amount of voxels in the scene, it also affects the scale of the simulated smoke. Think candle-sized smoke versus large building collapsing sized smoke. There's a difference, right? So we want to preserve the movement we got here, but somehow increase the level of detail. The feature we're looking for is a subdivision modifier, and in Blender language, that's called the Smoke High Resolution. This feature will allow us to increase the level of detail without changing the behavior of the smoke. What this also does is it adds a noise method called wavelet, and we're going to set this strength to 0 because in this particular video we won't need it. Okay, so now we have a good understanding of the smoke domain, let's take a look at the emitter. So if you focus on getting the emitter doing something else than just standing still, it will completely take your smoke simulation to the next level. First, let's do something about the shape of the emitter. The cube isn't really what we're going for today, so we'll try and give it a more organic shape. So to edit the cube, select Edit Mode, press T to get up this menu, press W and Subdivide Smooth. Play around with the settings here until you get something that looks more organic. Okay, so wait a second, we want to prevent the smoke from rising to the top. Right now the smoke is behaving as if it was steaming hot. Let's say we wanted to make it cold. So what we can do is we can actually lower the temperature difference and the smoke will go downwards instead. To animate the smoke emitter, we're going to use some keyframes. So make sure you're on the first frame of the animation. Select the blue arrow to move the emitter on the Z-axis until it's outside of the domain. Hotkey I for insert and select location. Let's move forward 100 frames and do the same thing, but this time move the emitter inside the domain again, towards the top. Press I for insert and insert keyframe on the location value. Now we have a really basic animation where the emitter brings some movement to the simulation. And if you enable the initial velocity feature in the emitter settings, the smoke will get a lot more movement from the animation and you get an even more realistic behavior of the smoke. So feel free to play around with keyframes here. In Blender, you can actually keyframe almost anything. For example, rotation, scale, even the color of the smoke. So feel free to create something unique here and we'll continue to the next part. Okay, so I went ahead and added some extra color and rotation just to try and make the final result a little bit more interesting now that we're going to put some lighting to it. What we're looking at here in the viewport is being rendered using Blender's OpenGL render engine. This engine is meant to be fast and smooth to work with, but it doesn't really have the features that we're looking for in our final render. So click this sphere and set the viewport shading to rendered. Okay, so first of all, everything suddenly became a lot slower. So we want to reduce the amount of pixels being rendered. go back to solid view, grab the top right corner and pull sideways. Then do the same thing again, but pull downwards and split it in half. Now, if you set the shading of the smallest window to render, it will be a lot more responsive. The smoke is missing some lighting and we want to use a bigger light source to get smoother lighting. So right click to select the lamp and press M to choose which layer it should be moved to. We'll add a flat plane object and give it a light emitting material. So go to Add, Mesh, Plane. Now the plane ended up over there. That's because the 3D cursor determines where new objects are being created. So to reset the position of our plane, the hotkey is Alt-G. Now move the plane on the Z-axis until it's above the smoke domain. And scale it up by pressing S. Currently our new light source is a diffuse plane by default, so we'll head over to the Materials tab and give it a new material. Under Surface, there's the entire list of materials we can choose from in Cycles. We're going to select Emission Material. Now increase the strength to make it brighter. This is looking actually pretty cool. To get even more contrast in the scene, we can get rid of the gray background by heading over to the World Settings and set the color to black. Now it looks a lot better apart from the huge white plane in our frame. We want to hide it, but we still want it to bring light to the scene. So select the plane, go to the Object tab, scroll all the way down to the bottom to Cycle Settings. Here you can disable the ray visibility for the camera. Now we can still see our light here in the OpenGL render, but it'll be hidden from our Cycles render. Okay, so we got our light source in the scene, but let's try and add some more. To view our scene from the side, press 3 on the numpad. We can then duplicate our emission plane by selecting Object, Duplicate Objects. Now a duplicated version of the plane follows your cursor until you left click. Press R to rotate, and you can hold down Ctrl to snap it. Now we have a large light source from above and another behind, but we need to adjust the camera. So if you stay in side view, numpad 3, you can zoom out until you see the camera. Right click to select it and reset its location and rotation by pressing Alt-G and Alt-R. As you can see, the camera is now in the middle of the scene, pointing towards the ground. So in side view, rotate it 90 degrees and move it to the left. Hover your cursor over the render view and press numpad 0 to see what the camera is seeing. Hopefully it should be pointed towards the simulation, and you can go into the camera settings and adjust its focal length to match the shot. Feel free to play around with the position of the camera and the lighting. To change the color of only one of the lights, select it and head over to the Materials tab. Here you can see a little number next to the material name. This number tells us how many objects are sharing these settings. So simply click the number to create a new copy of the material. Now you can make all the changes you like to the backlight without it affecting this other light, because they're two separate materials. Don't be afraid to use bright and vibrant colors. Play around with the lighting, make sure it looks good, and we'll get ready for rendering and exporting. Okay, so we're getting ready to render the smoke. You can either use your GPU or your CPU, but if you have a dedicated GPU, that will definitely be the quickest. Before we start our final render, we should bake the smoke in a higher resolution. Now, this baking process may take a while and fill up your hard drive space based on what level of detail you're settling for, so please be careful to not crank up the settings too high. As we talked about earlier, if we were to increase the divisions, our smoke would start to behave completely differently. But right now we're happy about its behavior, so we'll adjust the smoke high resolution values instead. I'm going for a domain value of 64 and a smoke high resolution value of 5. The wavelet noise strength is set to 0. To bake the smoke, scroll down to the smoke cache and simply hit bake. If this is grey out and you can't access these options, you simply need to save your Blender file before you can bake. Okay, now that the bake is done, you can probably feel that everything is going a lot slower. That's because there's a lot of data being calculated in the viewport right now. So to speed things up while working, you can uncheck the Show High Resolution button and you'll get a lower detailed version of the smoke in the viewport. The final render uses full quality no matter what this button is set to. Now that you've baked your smoke, it'll be interesting to see if your GPU has enough memory to render the simulation. If Blender crashes trying to load the scene while rendering, it means your graphics card doesn't have enough VRAM. So try lowering these values if Blender crashes during rendering with the GPU. So to render the animation, go to the Render tab, select the output for where you want to save your animation. We'll be exporting the animation as an image sequence, so prepare for a lot of still images. Actually, 250 of them. Set the file format to PNG and the color channel to RGBA. This includes the alpha channel, which makes it possible to render the smoke with transparent background, which again is really useful for compositing. To get the transparent background, scroll down to Film and hit Transparent. You can see that the render viewport also changes. You can test how long it takes to render a frame by pressing the render button and then adjust your settings accordingly. Okay, so right now I'll render at 1920 by 1080p, half resolution, at 64 samples for the sake of this tutorial, but in the final result I'm going to render at 1920 by 1080p, 30 frames per second, and probably 256 samples or 512. Now before rendering you can see that the emitter is barely visible inside the smoke still. So what you can do is you can press Ctrl H to hide it from the render. Now you can start the animation by clicking here, and when it's done, we'll do some post-processing in After Effects. Okay, so now we're in After Effects CC 2017 and we're going to import our footage. Go to File, Import, File. Find your image sequence and click on one of the images. Now before clicking Import, make sure PNG sequence is selected in the sequence options. After you've imported, right-click on the image sequence and select New Comp from Selection. And as you can see, the image sequence is now an animation and it has a transparent background. It's perhaps a bit grainy, but there's one big reason why we imported the sequence to After Effects instead of just rendering out the video in Blender. And that's because we're going to add some motion blur. So go to Effect, Time, CC, Force Motion Blur. Nothing happens. This is because we need to enable frame blending. I don't have any other explanation to this than to click this button twice and this button once. I'm sorry, they're quite small buttons and hard to describe, but now we have motion blur. And since we're already inside of After Effects, we might as well do some color correction. So right-click, Effects, Color Correction, Lumetri Color. Now if you haven't tried Lumetri Color before, it's a really powerful plugin that comes with After Effects, so I recommend playing around with it. Now if the motion blur takes too long to render, you can decrease the motion blur samples. 8 is probably too much, so you can set it to 4 and it's more than enough. Now to export this as a video file, go to Composition, Add to Render Queue. Click Output Module, and in the format try QuickTime for example, and in the format options, H.264 is a great option. This is probably way too much, but we'll leave it at that. Press OK, OK, and then select where you want to output the file. And there's our final result. It works kind of well because the motion blur makes the noise look like some sort of powder or something. So combine this with YouTube or Instagram compression, you may actually be okay with just 64 samples. And this video was made as a school project, so please leave a comment. It really helps me out in the evaluation. Thanks for watching.